Tonight we're going to continue our discussion on volume of prisms, and tonight we're going to talk about composite figures. So the objective is I can find the volume of a composite figure. What that means is a figure that's made up of two or more of the prisms that we've discussed. Maybe it's made up of a rectangular prism and a cube. Maybe the three-dimensional solid is made up of a rectangular prism and a triangular prism. And you can actually find the volume of these in two different ways. You can either add the volumes of each individual solid, the rectangular prism, then the triangular prism, or you can always fall back on area of the base times the height. That will work. Just might have to take a minute to find the area of the base. So like here, if we called this our base, we could always find the area of the base and multiply it by the height. Either way, either add the volume of the two figures given together or figure out the area of the base, multiply it by the height, you'll have the volume. I might do it both ways, who knows. So let's go ahead and take a look at this pentagonal prism. It's made up of a triangular prism on top here. In the triangular prism, the triangle part is a 1/2 meter tall, 4 meters wide, and 6.5 meters long. So those are the dimensions we're going to need to find the volume of that triangular prism. For the volume of the triangular prism, need an S in there, we need to take the area of the base times the height of the prism. So our base for our triangular prism is a triangle, so it's going to be 1/2 times the length for the base of the triangle times the height of the triangle, and then to that we'll take it and multiply it by the height of the actual prism, the actual triangular prism, and this will be the height. Once you find the area of the base, you just multiply it by that height. So this would be 1/2 times the length of the base of the triangle is 4 meters, times the height of the triangle is just 1/2 meter, times the height of that triangular prism is 6.5 meters. All right, meters times meters times meters, I know that's going to be meters cubed. 1/2 of 4 is 2, 1/2 of 2 is 1, times 6.5, that would be 6.5 cubic meters is what it would take to fill up the triangular prism. Now let's find the volume of the rectangular prism. Why do I keep forgetting to put my S in the word prism? Oh well, that would be the area of the base of that prism times the height of the prism. And now we're going to talk about this rectangular prism. The dimensions of the base are 4.5 by 6.5, and then the height of that rectangular prism is 6.5. So that gives us the dimensions for our rectangular prism. So now we're going to find the volume of the rectangular prism. So area of the base would be the length of the base of the rectangle times the height of the rectangle. And then once we get that, we'll multiply that by the height of that rectangular prism. Base of our rectangle is 4. Again, you could have also used length times width times height. Width of our, or the height of our rectangle on the bottom here is 6.5 meters, and then the height happens to be 6.5 meters. Meters times meters times meters is meters cubed, and I can do 4 times 6.5. That would get me to 26 times 6.5, gets me to 169 cubic meters. That's what it would take to fill up that rectangular prism. So to find the overall volume, the total volume, I would take the volume of my triangular prism and add it to the volume of my rectangular prism. So that would be 6.5 plus 169 cubic meters. And that gets you to 175 and 1/2. 175 and 1/2 meters cubed would fill up that entire prism. All right. What about if we looked at the same problem, but we just stuck to area of the base times the height? If we want to do that, we can just look at it as a pentagonal prism. And so to find the area of our base, here's what the base is what names the prism. So if it's a pentagonal prism, the base is this pentagon, and the height is how deep it goes. So for our area of our base, area of our pentagon base, times the height of our prism will give us our volume. That'll give us our overall volume. So for the pentagonal base, we would find the area of this triangle and the area of this rectangle here on the front. So the area of the triangle would be 4 times 1/2. It's a triangle, so it's 1/2 base of the triangle times height of the triangle. So the area is, for the triangle part, is 1/2 base of the triangle times the height of the triangle. And to that, we'll have to add on the area of this rectangle. And then it'll be the base of the rectangle times the height of the rectangle, or the length and width of this front rectangle. So that will be 4 meters times 6 1/2 meters. And we'll figure that out, and then we'll have to multiply it by the overall height of the prism. The height of the prism, this is the height of the prism, how far deep it goes. The base is the pentagon in the front. The height is how far back it goes. So that 6 1/2 is the reason the height of the prism is 6 1/2 in this case. All right, 1/2 times 4 is 2. 1/2 of 2 is 1, correct? 1 plus 4 times 6 1/2. 4 times 6 1/2 is actually 26. So we have 27 times 6 1/2. This is just another way to find the volume by doing the area of the pentagonal base times the height. And 27 times 6.5 had better be 175.5. It's not a different prism. It's the same prism as the last problem. I'm just giving you another option. So that's 175.5 cubic meters. And again, I don't care whether you do it the way we did on the last slide, where you found the volume of the triangular prism, the volume of the rectangular prism, and then you added them together to get your 175, or if you look at it as the area of this pentagonal base times the height. Either way, you're going to get 175.5 cubic meters. All right, let's find the volume of this figure. All right, for the volume of this figure, it will be the volume of the cube plus the volume of the rectangular prism. The volume of your cube, area of the base, length times width, it's a cube, 4 by 4. Oh, that's not a cube, sorry. I thought it was a cube. That goes back 6. Sorry, my bad. There's no cube. There's no cube. So volume of the rectangular prism 1 plus the volume of the rectangular prism 2. So this first rectangular prism, it wasn't a cube. This is 6 centimeters back. Sorry, once I really looked at it. All right, so this would be the area of my base would be 4 by 6. Okay. So this would be 4 times 6 times, how high is it? 4. So hopefully you can, I know I got a lot going on in this picture already. I just want to show you for this top rectangular prism, I'm just taking the area of my base, so I'm taking 4 times 6 to get the area of the base, and then times the height of that, and the height of that happens to be 4. Then I'll add to that the volume of this rectangular prism down here. For this rectangular prism, to find the area of the base, it would be 10 by 6, 10 times 6, and the height of that one happens to also be 4. So here, 4 times 6 is 24 times 4, 10 times 6 is 60 times 4, 24 times 4 is 96, plus 60 times 4 is 240. 96 plus 240 gets me to 336 centimeters cubed, cubic centimeters for the overall volume of this. Now, some of you might say, I would rather find the area of the base times the height. I have no issue with that, but you have to see, for this would be the base. I'm going to outline the base. That front face would be the base. And then how far back it goes would get you the height. So to find the area of the base, we'd have to take this rectangle and this square and add that together. So we could always do the volume as the area of the base times the height of the prism. And when we're talking that, you get the two faces that match. The front face and back face would be your base, and then the height of the prism is how far deep it goes. So the height of this prism is 6 centimeters. To find the area of my base, it would be 10 times 4, 10 times 4 plus, up here is 4 times 4. And then we'll multiply that answer by the height of the prism, which is 6. 4 times 10 is 40, plus 16. We'll multiply that by 6. 40 plus 16 is 56. We'll multiply that by 6. 56 times 6 had better be 336. 56 times 6, 336. The only reason I'm showing both of these methods is to just show you, even when we're talking about composite figures, you can still figure out the area of your base and multiply it by your height for your prism, or break it apart and find each individual prism's volume and then add them together. All right, hopefully that's either review of composite figure areas for you, or if it's brand new for some of you, I hope that helped.